phones inch toward real local AI. iPhone-class hardware is starting to feel genuinely capable of on-device AI beyond gimmicks. A developer reports Qwen 3.4b running around 25 tokens sec on an iPhone 17 A19 Pro GPU via Apple's MLX, a significant jump over iPhone 16 Pro, with better thermals and the GPU catching up to Apple's neural engine for local inference. The thread debates usefulness and quantization trade-offs. Some argue phones remain too constrained. Others point out 1.4b models feel snappy and, paired with search tools, are already practical for private, low-latency tasks. The post is from the maker of the Vector Space app in beta, but the observations reflect a broader trend of small models becoming usable on recent iPhones. Voice is joining the party. An iOS developer got Kokoro TTS running fully on device using the full 325 MB ONNX model with real voice embeddings, no server calls, producing natural 24 kHz audio in about 4 seconds per sentence and supporting 50+ voices across multiple languages. They integrate a speaking for phonetic handling and are considering quantization to shave latency. Others note iOS apps with local Kokoro already exist, underscoring how quickly high-quality local TTS is maturing. Open tooling is making local deployment easier on mobile. PrivateMind, a FOSS chat app with on-device inference and RAG, uses React Native Executorch. Models are exported to PT via Optimum Executorch, and the team is exploring a hybrid fallback to cloud for heavier tasks. Meanwhile, at the hobbyist end of the spectrum, a Gemma 3 1B Q4 build tuned for Raspberry Pi runs fully offline via Alima at 3.67 tacos for S on a Pi 4.5 with a local MCP-style tool registry to run scripts and read metrics, underscoring that useful agent-style workflows can exist even with very small models entirely offline. Open computing, shrinking freedoms. The ability to run what you want on machines you own is eroding, argues a Hackaday editorial that traces a clear through line. Consoles pioneered walled gardens. The iPhone normalized them under a safety quality banner. And Android and Windows have steadily tightened controls, often justified as security while advancing platform monetization. The result is less experimentation and a chilling effect on grassroots innovation. The piece's call to action, vote with your wallet, will resonate as more people attempt to deploy private, on-device AI and run into lockdown ecosystems with gatekeepers in the loop. Viewed through the lens of local AI, this tension is obvious. Users are increasingly interested in privacy-preserving offline models for chat, TTS, and tools, yet more platform layers sit between the developer and the hardware. That doesn't make local AI impossible, far from it, but it raises the importance of open runtimes and formats, and of platforms that allow users to choose what runs on their silicon. The practical upshot is a bifurcation. Rapid progress in open, local AI tooling, alongside platform policies that can constrain distribution and capabilities. The friction isn't theoretical. It affects whether an app can ship local inference by default or must fall back to a cloud endpoint. GPUs and local LLM throughput. Valve engineers quietly pushed Llama.cpp performance forward on AMD by contributing a RADV Vulkan improvement that boosts prompt processing throughput by roughly 13% on Linux. Community benchmarks on a Strix Halo running GPTOS 120 show PP512 rising from 521 to 624 tokens S, moving from Mesa 25.2.4 to 25.30 RC1, with ROCm still leading at 753 tokens per sec. Token generation, TG, rates remain close across stacks. Vulkan is narrowing the gap in prompt processing, improving the out-of-the-box experience for AMD users who don't want to rely on ROM. Meanwhile, would-be home labbers eyeing 72B models are reminded that VRAM, not cores, is king. Thread consensus. For dense 72B, target at least 72 GB VRAM for 8-bit near full quality or 36 GB for 4-bit with an expected 10 to 20% quality hit. Plan extra VRAM for context windows. Rule of thumb cited 1 GB per 4K tokens. Dual 24 GB GPUs can get you into 70B territory with quantization. Used MI50's 32 GB are a budget option, though power and setup complexity rise. CPU matters mainly for PCIe lanes to feed multiple GPUs. CPU offloading will kneecap token sec. Also consider VLLM for serving. The broader takeaway, software stack choices, Vulkan vs ROCm, quantization, and memory planning are decisive for throughput. Shaving double-digit percentages in prompt processing at the driver layer can mean the difference between usable and not quite there when serving large models interactively. Agents, tools, and MCP reality checks. Tool calling remains fragmented. Developers integrating Olama Cloud discovered that its tool call format lacks call IDs and doesn't support parallel tool calls, which complicates mapping tool responses back to specific requests. Some models, e.g. GPT-0120B, may not return tool call ID consistently, while others, e.g. Qwen3 variants, behave better. Filtering for models explicitly marked as supporting tools helps. Expect stop reasons to come back as stop, not tool calls. Model Context Protocol (MCP) support is also uneven in clients. A developer reported that Claude Desktop didn't react to MCP server-side notifications like send tools list changed per the TypeScript SDK, with no feedback from the MCP inspector either, raising questions about notification support versus polling-only implementations. This is the sort of portability friction that keeps agents from being plug-and-play. On the human-in-the-loop side, power users are noticing inconsistency in coding assistance. One account describes canceling Claude Pro for feeling dumbed down, finding ChatGPT Plus initially better, then also stumbling on simple SQL, while free Claude Sonnet one-shot the task. For everyday code completion and small transformations, these swings erode trust. Developers want predictable behavior more than occasional brilliance. Real-time long video understanding. Streaming VLM tackles the hard problem of understanding effectively infinite video streams with stable, real-time responses by aligning training with streaming inference and maintaining a compact KV cache. This avoids quadratic cost and the artifacts of naive sliding windows, enabling up to 8 FPS on a single H100 GPU. Impressively, it not only delivers on long-form streaming, but also boosts standard VQA without task-specific fine-tuning. On a new long video benchmark, the authors report a 66.18% win rate against GPT-4o Mini, a strong signal that tailored architectures can outpace general models for specific regimes like streaming. The repo includes end-to-end scripts, pre-processing live CC, SFT training in 2 stages, and efficiency benchmarking. Evaluation covers both public kits and in-house suites, VLMeval kit for VQA tasks, OVO bench for diverse video workloads, and Live Sports 3K CC for live commentary analysis. Practitioners can tweak inference FPS directly via a small code edit, making it straightforward to dial in latency quality trade-offs for deployment targets. Identity-faithful faces and fast image-to-video, with anyone, aims to break the identity versus copy-paste trade-off in face generation. Rather than pasting a reference face, it provides controllable, ID-consistent generation, including multiple identities in one image, while preserving flexibility over expressions, hairstyles, accessories, and poses. A key control is a slider trading resemblance in spirit, SIGLIP embedding, versus resemblance in form, ArcFace embedding, and it requires face-bounding boxes to tell the model where to render faces. A Gradio demo, LoRa merging, and evaluation scripts are included. The model weights are released for non-commercial academic use under Flux.1 Dev's license. On the video side, WAN 2.2 I2V pushes inference efficiency. A distilled, MOE-based image-to-video model that generates high-quality videos in just 4 steps, 2 high noise plus 2 low noise, and without classifier-free guidance. The team emphasizes high-noise 2-step training improvements for dynamics consistency while reusing WAN 2.1 LoRa's for low noise. The LightX2V engine accelerates inference. Recommended settings use the Euler scheduler with shift to 5.0 and guidance scale 1.0. The model is Apache 2.0 licensed. The through line across both projects is precise control of identity fidelity in images and of temporal coherence and speed in video, signals that generative media is maturing from can it render to can it match intent fast, reliably, and safely. OCR becomes document AMs have transformed OCR from transcribed text into reconstruct documents. A comprehensive guide shows modern models preserving layout, parsing tables, charts, captioning images, handling many scripts, and producing machine-readable outputs, HTML, Markdown, doc tags, suited to downstream QA and retrieval. It covers when to fine-tune, choosing formats, building evaluation sets, and deployment options from local, e.g. MLX on Apple Silicon, to managed endpoints, Stacks like VLLM and SGLang can cut serving costs and latency. Reward modeling is also entering the document arena. Doc reward targets structuring and stylizing outputs, teaching models to prefer document reconstructions that are both accurate and well-formed. Integrating reward feedback into generation can lift end-to-end quality in ways that raw likelihood training doesn't capture, especially for complex multi-element documents. Put together, these advances point to OCR that operates as a full document understanding stack. Robust parsing, structured outputs for databases LLMs, and higher-level reasoning over heterogeneous page elements. Security, autonomous agents, and Unix privileges. An eye-catching claim from LinkedIn. An AI security agent autonomously found and patched a zero-day in Netty, CVE 225-59419, a widely used networking library. The post says the flaw could have allowed forged emails to bypass SPF, DKIM, and DMARC, and that the agent analyzed code, produced a fix, and submitted it upstream without human-written patches. Maintainers' cooperation is credited. The broader message is the shift from reactive to autonomous defense. Given the venue, treat it as a notable data point rather than a new baseline. Defenders should also remember that Unix privileges have more facets than SHU-ID bits. A deep dive on Linux capabilities shows how setcap can grant powerful rights, e.g. cap set UIT to binaries without setting SUID, enabling stealthy privilege escalation. The author demonstrates spawning a root shell via Python with only capabilities tweaks, and provides commands to enumerate capabilities, get cap R, inspect process caps, and review extended attributes, get fatter. Tools like linps help hunt for misconfigurations, elastic documents detections for setcap usage. The juxtaposition is instructive. AI can help find and fix vulnerabilities faster, but attackers and red teamers can also exploit under-monitored privilege features. Security programs need automation on both detection and hardening, and an audit routine that goes beyond the usual suspects. Infra updates, auth and file systems. On the database side, the OpenFGA team describes rewriting their authorization system to run in pure Postgres, collapsing a multi-store architecture into a single backend. The write-up explains how and why they did it with an eye towards simplifying operations and aligning performance with a ubiquitous relational substrate. For teams wary of managing multiple distributed stores just to authorize users, the appeal is obvious. In kernel land, an NTFS file system remake, dubbed NTFS Plus, has been posted to LKML. The public link currently gates access behind Anubis proof of work to deter scraping, but the subject signals ongoing work on NTFS support in mainline discussions. File systems remain the quiet backbone of self-hosted compute. Improvements here ripple upward to everything from local AI datasets to scratch space performance. Reducing operational complexity, single-store auth, and strengthening storage layers, file systems, are the sorts of pragmatic, unglamorous wins that make it easier to run serious workloads, including AI, on your own infrastructure. Section Beyond Autoregression, Music and Diffusion. Amadeus addresses a mismatch in symbolic music generation. Models often decode note attributes, pitch, duration, velocity, instrument, type, as if they were a temporal sequence, but empirically the decoding order barely matters, suggesting attributes are concurrent, not ordered. The authors propose a two-level design, autoregressive generation across notes, coupled with a bidirectional discrete diffusion decoder within each note's attributes. With representation learning enhancements, MLS contrastive objective, and a conditional information enhancement module for better conditioning, Amadeus reports at least 4 times speed up over prior methods while improving quality and offering training-free fine-grained control. It supports unconditional, text-conditioned, and attribute-controlled generation. Diffusion is also making inroads in language modeling. R&D1 base 0910 is a 30.5B parameter sparse mixture of experts diffusion language model, 3.3B active per token. Converted from a pre-trained autoregressive base, Qwen 330BA3B. Text is generated by iteratively denoising over multiple steps, enabling parallel token updates within each diffusion step, a different speed-quality trade-off than left-to-right decoding. The release notes it's not post-trained yet, expects some repetition with greedy decoding, and suggests optimized MoE kernels, FlashInfer, and SGLang for faster inference. Taken together, These lines of work probe a bigger question. Where does autoregression remain essential? And where can bidirectional or diffusion-style decoders yield better controllability or efficiency without sacrificing coherence? The answers are becoming domain-specific, and that's a good thing.